So, hello again guys, it's me, Federico Tigbak. So, it's a day for I create a PowerPoint presentation about summary chapter tutorial of the chapter 8. So, let's go. To the PowerPoint. So this will be the chapter 8 summary tutorial. So in this chapter began with an introduction to routing, including a loop, the difference between routed IP and IPX, and routing RIP and IGRP protocols. So the communication process on a simple one router network was described step by step and included an overview of the different process that takes place when a host on one network attempts to communicate with a host on another. So, a more complex example involving the multiple routers and networks demonstrated the way in which routers will forward packets to the next hop address on their journey between a source and destination host on different networks. A look at static routing provided an overview of how this technique allows an administrator to manually define the path that a router will choose in reaching a network. This included a look at the IP routing table, the syntax of the IP route command, the concept of administrative distances was also introduced in order to illustrate how a router makes decision on which routing table entry to use when a path to the same network is learned in different ways. So, for example, static routing table. So, the table will entry always be considered more trustworthy than a route learned from a routing protocols by default. So, a look at dynamic routing demonstrates how routers are capable of exchanging routing table information with one another both through the use of distance vectors and link state routing protocols. So the major differences between both types of routing protocols were outlined, as was the concept of the hybrid protocol. The danger of routing loops was also discussed, including a look at the techniques used by the distance vector protocols to avoid these loops. An overview of the distance vector routing information protocol outline. Its major characteristics, timer, values, and finally commands to configure and monitor RIP on a Cisco router. So the interior gateway routing protocol was also discussed, including an overview of each configuration. So, for the default routing was looked at as a way to configure a gateway of last resort. So the hop router to whom a router will send packets destined for unknown networks. IPX routing was looked at next, including the fact that IPX, RIP, and SAP messages are broadcast between routers automatically after issuing the IPX routing command. So, IPX routing was looked at next, including the fact that IPX, RIP, and SAP messages are broadcast between routers automatically after issuing the IPX routing command. So we will go to NetAcad. So this will be the continue. Bitcoin 3. So okay, the subnetting using ID, the 16-bit subnet ID section of the IPv4 global unless address can be used by an organized great internal subnet. The subnet provides more than enough subnets and host support that will never be needed in one subnet. For instance, the 16-bit can create up to 65,536 by 64 subnet. This is not included the possibility of borrowing any bits of interface ID of the address. Support of 18 quintillion hosts of so the IPv6 subnetting is also easier to implement than IPv4 because there is no conversion to binary required to determine the next available subnet. Just count up in hexadecimal. For example, assume an organization has been assigned in 2001 0DP 8 and ACAD global routing prefix with a 16 subnet ID. This would allow the organization to create 64 subnet as shown as the figure. Notice how the global routing prefix is the same of the subnets. Only the subnet ID as the hextet is the incremented in the hexadecimal of each subnet. So that's all for now. Please don't forget to subscribe.